this video we're going to cover the cubic, which you can see on this screen. So a cubic equation, before we begin, is where the highest power of x, or some sort of variable, is known as is 3. So this is known as a cubic. So on your screen you can see some examples. We've got y equals x cubed, so 3. Y equals x cubed plus 2x squared minus 5x plus 10. And y equals negative x cubed plus 3. So cubic equations form a cubic when they're graphed, and these have a highest power of 3 for the variable. So when we're graphing y equals ax cubed, it's very similar to what a parabola is. So a still controls how wide or narrow the cubic is, as well as a also controls if the cubic is increasing or decreasing. Now, again, the smaller the a value, the wider the cubic, so the further away from the y-axis. And then the larger the a value, the closer to the y-axis the cubic is, so the narrower the cubic is. So on your screen you can see y equals x cubed, and that's the basic function. Now if I had something such as y equals 3x cubed, because that's a bigger value there at the front, that's a 3, it's a lot closer to the y-axis than is y equals x cubed. Now, in both examples here, a is positive, so the cubic is increasing, and what I mean by that is it's going from the bottom left to the top right. At all times it's going up, other than when it crosses 0, 0, which actually meant to flatten out and then keep going. My drawings are probably a bit poor for that, but I apologize. Now the next thing to remember is if a is negative, so in the green graph there, the cubic is decreasing. So when it's positive, it's increasing, like red. When it's negative, it's decreasing, like green, from top left to bottom right. So here we have graphing y equals ax cubed plus c. So again, the same as linear equations and as well as parabolas, c controls the y-intercept. Remember, it's some sort of a constant at the end. It's just a number, but it tells us where the cubic crosses the y-axis. So at this point, y equals x cubed, no number at the end, so it's crossing at 0. If I introduce y equals x cubed minus 3, it's crossing at minus 3. So on your screen, we're going to go through everything we've just learned. Feel free to pause the video now to try this out before I go through it. But we're going to match up each graph with its equation. So the first one is y equals x cubed minus 1. So the first thing I'll look for, is that a positive x cubed or a negative? It's a positive, so I know I'm increasing, which means it's going from bottom left to top right. Now we have minus 1 at the end, so I know I'm looking for a y-intercept, or where it crosses the y-axis, at negative 1. So that would be number 2. The next one we have there is y equals negative x cubed. So because it's a negative, I know it's decreasing, so going from top left to bottom right, and the only graph there that it has a negative is our number 1. The next one is y equals x cubed plus 2. Again, it's a positive x cubed, so I know I'm increasing, bottom left to top right. I'm looking for where it crosses at plus 2, so that must be number 3 right underneath. And the last one obviously is number 4, but if we have a look at it to make sure we're right, we know it's positive, so bottom left to top right. We have a 4 out the front, so we would expect it to be closer to the y-axis than any of the others. And if you take a close look, you can notice that it is actually a lot closer to the y-axis than the other 3. So that would be our number 4.